Here with number 9, which investment will earn more money? A $1,000 investment for 5 years at 8% compounded annually, or a $1,000 investment for 5 years compounded continuously at 7%. And so again, we're comparing two investments, everyone. We'll start with the first one. We are putting $1,000 in the account. We don't know how much it's going to be worth at the end. It's going to be in there for 5 years at 8%, so 0.08 for our rate. And it's compounded annually, so once a year. And I is R over M, N is MT. So 0.08 over M is 1, so that's going to be 0.08. MT is 1 times 5, so that's going to be 5. And this is compound interest, and so we do have S equals R times 1 plus I to the power of N. And so I can't remember which one was the last one I copied. I think it is compound interest. So there's my compound interest formula. We're putting $1,000 in. I is 0.08. N is 5. And we get that in 5 years. And I should do my math over here on the side real quick. So S is 1,000 times 1 plus 0.08 to the power of 5. And we did get S is equal to 1469.33. So in 5 years, the $1,000 grows to a value of $1,469.33. $1,469.33 is what we end up with on that $1,000 investment, gaining almost $500. If you need to pause here to take notes, go ahead, because I'm going to move on to part B now. And so for the next one, we need a new Surmton. And we end up with still $1,000 getting put in. We don't know the future value. The rate on the second one is 7%, so the rate's a little bit better. M, we don't get an M because this is compounded continuously. And T, it's for 5 years again. So the thing to notice, everyone, is that everything is the same. It's just that we have two different options for investing this $1,000. One is compounded annually, the other at 8%. The other is compounded continuously at 7%. So I think I misspoke earlier. The 7% here, the rate is not as good. The rate for the 8% is better. But we'll see if compounding continuously has an impact that is big enough to beat the higher rate from the compounded annually. So S is equal to 1,000. E, the R is 0.07, and T is 5. And so I'm going to have to run up to the top of this darn thing and grab my formula. There we go. And so I get, for R is 1,000, and then 0.07 times 5 on the other side of it there. And so in this case, we end up with $1,419 and 7 cents. So in 5 years, the $1,000 grows to a value of $1,419.07. And so we can see that the compounded annually, the first one with the higher interest rate did beat the continuous compounding with a little bit lower interest rate by about $50. And $50 is not necessarily something to write home about, but it did outperform the other option.